Airbus to talk about the work they've done on the safety partnership, but also Alan Smiley, who participates in some of the step change groups and particularly workforce engagement. And we're going to share just some of the key work that's ongoing and some of the challenges perhaps that we face collectively going forward. But for the purposes of simplicity, what I want to do is just give you kind of an introduction to step change. And in the hope that, just for those that don't know, step change is a member-led, member-funded and member-owned tripartite organisation that through collaboration aims to make the UK the safest place to work in the worldwide oil and gas industry. What that means is that for us, tripartite is the employers, both helicopter operators, production operators and OEMs like Airbus and Sikorsky and the like, but also the trade unions, so the trade union representatives through BALPA, RMT and also Unite, which gives us that real workforce voice combined with actually genuine elected safety representation at the leadership table. And finally, it gives us that regulator input both from the Health and Safety Executive and the Civil Aviation Authority in the terms of helicopter safety. So those are the three sides of the step change triangle and making sure that we continue to work on collaborative safety improvement solutions. Step change works on a really quite a reasonable kind of budget, but it's all about where we best spend our money to drive that collaboration and improvement. And the team is made up of only 6 people, but the sweat equity and investment from industry is hundreds of people every year to ensure that we work together to collaborate and continue to improve. So apologies for the busy slide, but this kind of gives you an insight into our strategic themes. And I'm still trying to wait for the slide on the webinar to catch up. There we go. So this gives you a kind of overview, and as helicopter safety is what we're speaking about today, it is at the top of the triangle. But there are 5 strategic themes within step change. So we have asset integrity and hydrocarbon release prevention. So that's about assuring the integrity of our offshore environment and maintaining that sort of hydrocarbon envelope that we get best production, but also manage safety in a good way. And a huge amount of activity in that area has been ongoing for a long number of years. The hydrocarbon release reduction program, we're at a lower level than ever before. That is linked to then the competence and human factors piece, which is about do we have the right competence and the right human factor skills to manage risk in our business, supported through the big line at the bottom, which is fundamentally workforce engagement, and recognising that the workforce comes in many shapes and forms, both on and offshore, and it also includes the leadership. So that piece that we need leadership and workforce engagement to drive the agenda is incredibly important. In the centre there, what we have is the latest strategic theme, which is simplification. And that's about us trying to drive standardisation, harmonisation and consistency right across the UK industry. It's a huge challenge, but arguably helicopters is an area where we've been incredibly successful at that. Through the work of the helicopter operators, the Joint Operator Review has driven a standardisation agenda. Perhaps easier when you only have 3 or 4 helicopter operators on an airfield, when we're looking at maybe dozens of production operators across the North Sea. But that opportunity to make things simpler and further engage the workforce just has to be good business sense for everybody. And then helicopter safety. It has been, as everybody knows, at the centre of the agenda for quite a long time, and that continues to dominate, let's say, people's consciousness. But I think today's session actually just shows how far we've come. This is incredibly positive in terms of the level of collaboration, the level of commitment from industry, and actually the level of engagement we have with the workforce to actually continue to drive the improvements. And we'll share some of that with you today, some of the challenges we've faced, some of the things that are going on in the future, and then ultimately what we can do perhaps slightly better. So apologies again, because there appears to be as much as a 15-second delay between the slides flipping over here. But who is HSSG? So HSSG was formed actually in its infancy back in 2009. It used to be called the Helicopter Task Group, and that was formed around the tragic Mallard incident. What came out of that was industry managing the response to that incident and following the AAIB report. Since then, we've gone through a number of incarnations, but recognising that HSSG was part of our helicopter safety, was part of how we needed to manage our offshore operations in a slightly different way, we created HSSG as a standing collaborative space to continue to work and build on the work of HTG. So you can see there who's involved. So Civil Aviation Authority, Heli Offshore, the helicopter and operator and OEM trade association, the trade unions, helicopter operators, oil and gas operators. We have BALPA, obviously incredibly important to have BALPA in terms of getting that pilot view. The Health and Safety Executive, but key links to other areas of helicopter activity through IOGP and ASTG. ASTG is the Oil and Gas UK Aviation Safety Technical Group, and they are tasked with running a huge number of work groups on behalf of industry, things like weather data network, multilateration, and engagement with things like NATS and air traffic control. Where HSSG is now working are things like Category A ABS, and we'll come to that through today's presentation, passenger size and the success of both those projects, and actually the challenge of implementing heli-deck lighting across the UKCS and the timeline that we have on that, and that's something that we hope to share. But it's probably quite important to recognise why HSSG still exists and also what we've done. So this is not about just always reacting to its latest regulatory impact. It's about the proactive work we've done through the EC225 return to service, the huge level of workforce engagement and collaboration to get the information into the UK offshore environment, but actually beyond the UK. The work that Step Change and HSSG led on the 225 return to service was used globally as standard communications and engagement tools for the workforce. And that played out again in response to the Summer accident in 2013. And we continue to see the coalescing and collaboration around HSSG and how to drive that improved performance. So hopefully we'll get that. So what I want to just start with is just the strategic aims of the Helicopter Safety Steering Group. And if it pops up on your screen very soon, I will be extraordinarily happy. But I mean, the key is that actually it's set up to address cross-industry issues around helicopter safety and continue to strengthen the confidence in helicopter travel. Why is strengthening confidence important? Because ultimately, for those that travel, they need to ensure that those that are responsible for managing the risk are doing that in a joined-up way. And that's at a helicopter operator, manufacturer, and production operator level. So it's having the right people in the room and making the right decision. And the strategic themes hang off that is communicate regularly, openly with the entire workforce to make sure that any issues, any concerns, we have a platform to raise, action and respond to. It's also about improving knowledge and experience, and we use this sort of term to T-shape, and that's about recognising that there is a real role for passengers in aviation safety. And whilst the importance of maintenance and the importance of pilot training, etc., cannot be underestimated, the role of the passenger in that sort of flight envelope is critical, both in terms of good communication, between cockpit and cabin, but also in terms of how we manage things like return to base and all that level of engagement. And that's about knowledge and understanding that return to base is an important part of just regular flight safety. And then, we look at the implementation of CAP 1145, the actions and recommendations that came out of that. And Step Change isn't responsible for them all, but where we are, we've taken the lead and driven that improvement in a really, quite aggressive manner to make sure that we, have the very best of equipment and the right solutions, to maintain, safe flight operations, but also to maintain everybody working in a safe environment. And it's, and I think they go hand in hand. CAT ABS was driven in a very expedient manner to ensure there was no disruption to people travelling to and from offshore. And we have some information to share on the back of that. but recognising that what we learned in CAT A ABS we improved in terms of passenger size and the implementation of that. So I'm going to start with Category A EBS in terms of updates, and just what are the key things that that we've kind of identified and the sort of the lessons that we're continuing to learn. So first and foremost, and most, I guess, that the lap jacket. So the old lap jacket and rebreather was removed from the training environment on the 15th of February. The new APITA standard is in place and now effectively integrates the dry elements of the CAT A EBS training. One of the things that we've not been able to achieve, and I'm hoping and I'm convinced there'll be lots of questions around this, is that we are unable to get the CAT A EBS training in water at this time. And there are a number of issues from that, but the long-term goal is to continue to work towards providing in-water training if it can be demonstrated that it's safe to do so. And the issue is around the applicability of the diving at work regulations and the health and safety executive's position that they do apply. And there's a huge amount of work going on in the background to fully understand the risk and the benefit of doing wet training. And it is about the benefit of doing wet training. I think it's extraordinarily important to recognise that this is about training and training alone. The CAT A EBS is a fundamentally better piece of equipment than the rebreather that we had at the time of the Sunburn incident. It gives people a much greater chance of egress and dry air should they need to use it. But all the work that the helicopter operators, Heli Offshore and Airbus are doing is actually to ensure that we never ever have to use this piece of equipment in anger. So the only place we should use it is in the training environment. And why is that different? It's because in the pool we'll do 5, 6, 7 exercises potentially using it in water. And it's to do with that frequency that presents the cause for concern from the health and safety executive. The number of ascensions in terms of coming up from what is perceived depth, and it's only about 1.5 meters, but that is the perceived risk. And coming up from depth in a water environment, breathing higher in atmospheric pressure air, presents a potential risk of barotrauma. And so that has to be managed, and that risk is minuscule, but we have to get through that regulatory piece. But recognising that in the event of a tragic accident offshore, it is there as a piece of life-saving equipment, and by far the benefit by far outweighs any risk of barotrauma in that kind of environment. So there's a real message there that the training environment presents different risks from use in an operational or live environment, and making sure that we get that balance right in terms of risk and benefit. But this is not going to be an easy fix. What we have is the requirements from the CAA, the position of the regulator, the aim of the industry working towards a much better wet training environment, and actually a demand from the workforce that they want to use the tool that actually, the right tool in the right way. So what we've got is a solution that's not training people on the wrong piece of equipment, but we haven't managed to get to the point of training people in the equipment in which we want. And I think it's just really important to be completely honest about that at this session. So happy to take any questions on that as we go.
We have a question.
So guys, we have one question. So Emily's going to throw it over to me.
Were the training difficulties identified as an issue before the CA EBS was being considered?
So actually, the industry was working on a previous note that the health and safety executive had given industry, that the diving at work regulations didn't apply, and therefore there was a belief that there would be no requirements to meet. Once you go through the challenge of training 37,000 people, in a particular calendar year, the exposure goes up from training, maybe a few hundred pilots per year, and pilots are, they have a different level of medical because they are obviously carrying passengers than our average offshore medical. So there was a sort of almost grandfathering through, or the principle that we grandfather through the old exemption, or the fact that they didn't even apply. So yes, it was considered. When it was considered, it was believed that it could be managed, but the risk aversion of the doctors and the medical advice has got us this position. And that's about industry ultimately presenting a case that demonstrates that this can be done safely. And the work to look at what the British Sub-Aqua Club is doing and Paddy and everybody else is doing in terms of diver training in a wet environment, in much greater depths and in open water, will help us understand any perceived risk. And that's ongoing. But it was considered, perhaps not as well as it should have been, but that doesn't eliminate the benefits that we have in currently carrying the new piece of equipment. Faster to deploy, simpler to deploy, and ready to go in the event that we need it. And I hope that answers the question. So we're going to come on to passenger size and the work that we did. And if there's one thing we've learned is through the use of Category A EBS, it's the challenge that presents commercially to everybody when we're training 70, 80,000 people, and how you deploy that into an environment where you're having to measure 70 to 80,000 people. So the first thing is that CA EBS, we estimate cost industry something like £20 million to implement. And that's about moving people around, putting them through 90 minutes of training and managing that deployment. And that's a huge burden on industry, a huge burden on the workforce in terms of travel and expectation. And that was just unacceptable from a step change perspective as we moved into the challenge of passenger size and managing that regulatory burden. Now, you could argue till the cows come home, and I'm sure many do, about the efficacy of a bideltoid measurement and the shoulder measurement. But what we had to come up with was a single, simple measurement that allowed us to effectively give us the best measurement and the best retained measurement for compatibility with the escape windows in the aircraft. And that's hugely challenging, because if we had all the time and all the money in the world, we could do 3D body scanning for an entire workforce. Now that's a huge burden on passengers, a huge burden on industry, and fundamentally doesn't really give us much of a different answer from looking at the skeletal structure. What you can see from the slide is actually we've measured 75,000 people, and there's only 2.5 or 2,200 of those that actually require specific seating arrangements within the aircraft. Now, coming back to the fact that and you can see the grey seats there on the slide in front of you are the seats that are allocated for XPR. This very quickly realises there's more than enough capacity to seat those. It's about 3% of the population, and on average, you've got about 30% of the seating available for extra broad. There is no super extra broad at all have ever been recorded in the UK, and there is capability to manage that. But again, when you're only looking at a tiny population in extra broad, this has become really quite a small issue in terms of logistic. By using offshore medics, what we've been able to do is actually have it done at site at little or no cost. Now, the medics have obviously had to be trained, and Robert Gordon University have provided the initial training deployment for that, which gives it that kind of assurance from a standards perspective. But what that means is that the vast majority of those 75,000 people had measurements at site at no cost during their workday. And when you compare that to the cost of Category A EBS deployment, we were able to roll out passenger size for an estimated £1 million. Now, it's still a huge number, but if we'd used passenger size and used exactly the same model of EBS, that would have been £14 million additional spent. And that's what we're trying to work now, and right across step change, and particularly in aviation safety. How do we get the right safe outcome at the best possible cost to be incredibly efficient? But we do know that this is an area where things are not working as well as they could. And thanks to a member of the workforce who wrote to us just in the past month, they have highlighted a potential issue. And that's about the use, or the appropriate use, of armbands. And I guess, in all honesty, the potential social stigma that comes attached with classing yourself as extra broad. Now, there's even wearing a green armband, as I have to do when I travel offshore, because it's usually the first time I've gone to an installation, the fact of the matter is that there is some sort of social stigma attached with identifying yourself as something different. And we need to tackle that as an industry. But apologies, so I'm going to come back. So the armband policy is very clear in terms of how we manage this. I'm hoping that the slides are going to catch up again with you. But your XPR data is recorded in Vantage and on the flight manifest. And when you are given your suit, you should be given an appropriate armband and a disposable one to put in your pocket for your return journey. Thanks to the anonymous reporting of an offshore worker, this has been advised to us that it's perhaps not as efficient or being used as appropriate as it possibly could be. And I really want to try and use this session to gain some feedback as to, are people wearing the armband? Is it working? Are we using it at site? And I think particularly in the inbound journey. So where we have the robustness of, let's say, pre-flight checks at the heliports, when we're offshore, are we following the good buddy check process? Are we wearing the armbands to make sure that we're sitting in the right seat, compatible body size, and managing it effectively? So I think Emily's got a poll for us, and I'd just kind of like to get some feedback. So are you aware of any issues on this? Yes or no? And or not applicable?
Okay.
So the good news is that some people, the vast majority, don't know, which is, I guess, maybe a sign that we've got quite a lot of onshore people here on the webinar. But some 41% saying that they're not aware of an issue. I think it's 9% that says there is an issue. So I would encourage that if you don't think this is being deployed properly, can you please write to hssg@stepchangeandsafety.net, you can write anonymously, or you can write, give us your name, because we would dearly love to give you feedback that we're actioning this, and we will pick it up with through HSSG and through the helicopter operators and ultimately onto sites to make sure this is addressed. Because this is a regulatory requirement. It's important that we get this right. It's also incredibly important that people continue to set themselves in the correct seat. And this is this is just common sense. If you are too big and your shoulders, are not deemed to be compatible and get through the window, you want to sit in that seat and manage it. So that you're given the best chance of egress. And this is, again, this is one of these simple things that we can do just to improve the overall envelope of safety in context of everything else, that you should never ever find yourself needing to do this. But dead simple and very, very efficient. And I think that's the idea about this. This is not about creating a huge burden on an industry. It's about just putting people in the right seat to give them the best chance in the event of something, the unlikely event of something going horribly wrong. So I'm going to come back to, finally, in terms of what we've decided to do with regards to how do you manage the XBR issue? How do you manage 75,000 people being measured or remeasured? Because quite honestly, we don't want to create a cottage industry. And I think there are many, many people who would happily send those 75,000 workers who've been measured back through the rinse and repeat cycle of being measured and remeasured time and time again. So the decision is actually much simpler than perhaps you might have experienced in the past. So there's a population that we think will require to be remeasured, but if you're not in that population, once you've been measured, then that's it for life. Your body size changes, but it doesn't change sufficiently to fall into this kind of, that you'll ever become either small enough or big enough to need to be remeasured. So the magic number for XBR is 55.9 centimeters. So it's basically that plus or minus 10%. So if you're less, if you're less than 51 centimeters in effect, you should never need to be remeasured again. It would be highly unlikely, unless you're a Russian tennis star, that you'll ever put on sufficient muscle mass through performance-enhancing drugs to become big enough to be remeasured. And if you're bigger than that, what's the number here? 60 centimeters here. Then it's very unlikely that you'll ever lose sufficient muscle mass or soft tissue to ever be below that 55.9 centimeters. So linked to Bosiet, we reckon that there should be a sense check once every 4 years to measure any difference, and that will then give us that opportunity. So what we're trying to encourage the Vantage user group and the employers to do is that 3 months prior to your Bosiet renewal, no matter when it is, so this is not, again, let's try and keep it simple and make sure that it's aligned to something we're already doing. There'll be a flag and a note in the system to say you need to be remeasured. In an ideal world, that'll be delivered at site by your medic, and that data will be verified and uploaded into Vantage. If you're not offshore, there's obviously the network of measurers that can continue to deliver the service at a cost. But we really want to encourage everybody to use their offshore medics to continue to get this done if you fall in this window. And that's about managing costs. That's about minimizing disruption and not having to travel to a measurement center for what is literally a 5-minute exercise. So get your medic engaged, get your site, get your offshore logistics engaged, and make sure that this can be done in a dead simple, straightforward way. And really, from a simplicity perspective, that's it. So once every 4 years, done at site by the medic, but only if you're in the category where you could theoretically lose or gain sufficient mass to make a difference in your XBR status. If you're out with that, then you will never need to be measured again. What we're going to do with trainers and measurers is, as long as they remain current and continue to practice, they will be able to continue to train and measure people. If they stop training for a period of up to 2 years or stop measuring for a period of up to 2 years, they're going to have to go through refresher training to make sure that they are meeting the criteria of accuracy of measurement. But again, it's about simplicity and not driving a training and measuring standards organisation or anything that creates a further burden on industry. Recognising that right now, times are very hard and that we need to just keep it simple and cost efficient whilst delivering the right and safe outcome. So on that, I'm conscious that you've been hopefully listening intently. I'm going to invite Mark Abbey to join me, and Mark and I will perhaps take some questions about the work of HSSG, anything that perhaps you would like us to see us focus on going forward, and then post that we'll hand you over to Andrew Dettel of Airbus and Alan Smiley from TACA.
Okay, so we have a number of questions. The first question was about the EBS. The graphic shows the SurviveTech EBS. What other suppliers are certified as CA EBS?
Do you want me to take that? From a passenger standpoint, it is the solution that we've chosen is the SurviveTech solution. There is alternative EBS systems, but right now we're not deploying them in UKCS. Other than for crew, there is 2 standards for the front of the cockpit. There is a SurviveTech jacket, which is similar but slightly different to the passenger standard, and there is a Viking jacket. So there's 2 suppliers for the crew, and it's really down to preference, ergonomics and fit. Both of them meet the regulatory standard and both of them do the same thing. But the answer to the question for the passenger is there is just the one standard right now.
I think just to add to Mark's point, in other regions, in the Netherlands, I believe that they have got a solution that's CAT-A certified by CAA. It's a different solution than the one we have in the UK. That doesn't mean to say that it can't be deployed, but again, one of the challenges that we face by bringing in new equipment is that there's additional training burden, and making sure that because there's a requirement to have effectively product-specific training, if we bring in a new piece of equipment, what we have to do is train more and more people and more in different systems. That makes it difficult for things like flybys or medivacs, etc., in terms of sharing of flights and everything else. So there's good reasons for having the Survive Tech Mark 50 as the answer, but that doesn't mean to say that we're stuck with it. But to change out en masse is challenging. But ensuring that Survive Tech also maintain, let's say, the integrity of the kit and continue to develop it, so that the piece of equipment we've got was derived from a military piece of equipment, purely about ease of deployment. It was the recommended piece of kit from CAP 1034, which was the CAA research paper that talked about Category A and Category B emergency breathing systems. So what we did was we picked the very, what was deemed to be at the time the very best piece of equipment, and there are certainly other models available, but this certainly, from a cost efficiency perspective and an ease of deployment, that's where we're at today. Where it's going, it's difficult to say, but there's an ongoing improvement or continuous improvement work with Survive Tech and HSSG to ensure that we, particularly from the work that's going on for pilots, that we can learn some lessons and further improve the equipment as we go.
Okay, the next question. Why are we training people to hold their breath when that is the last thing that we want them to do with the Category A EBS?
So I'll take this because it's the very best we can achieve right now, if you want an honest answer. The ideal scenario is if we can demonstrate it's properly safe to train in water, then we can move the diving at work regulations and the exemption and the medical requirements. The medical requirements, it was felt that they placed quite a considerable burden on the offshore workforce, and there's a risk that people would not be able to get through the additional medical steps. The consequence of that is that you end up with potentially a two-tier system where some people could do it in water, having met their medical requirements, and some people only doing it dry. Now, that just gives the industry a logistical burden, but also runs the risk of people believing that they're not able to fly offshore. And the reality is that we want to avoid that at all costs. We want to avoid the consequence or the unintended consequence of somebody not achieving the medical requirements and then being put at risk for no other reason than they can't do some very simple training. So we have to manage that. We have to engage HSE, and that's ongoing. But, so we are where we are. The best we can offer in terms of training right now is training in the pool, but using breath hold. To continue to train in lap was just counterintuitive when you're actually now flying in the UK with the new Survive Tech Mark 50. And that's, so training in the wrong piece of equipment we felt was a much poorer outcome than not training or kind of using breath hold. And breath hold still is, an effective way of egress. But what you have here is a big yellow mouthpiece, and in the event that you have to use it, it's as simple as, stick the big yellow thing in the big pink hole, and there's a fair chance that your life's going to be a lot simpler.
Okay. The next question. The letter released a couple of weeks ago stated that the burden to the industry was too great to bear at the current time. Most people have read into this that the real issue is around the cost of recharging so many cylinders. Is this a factor?
Not at all. Actually, the burden is that we've actually felt that people's jobs could be put at risk. And as a result of that, we didn't think it was an acceptable outcome in the current environment when we're managing rota change and everything else at, $40 oil or whatever it is today. So the burden was about putting people, the risk or our perception that this potentially put people's jobs at risk. And as an industry, we felt that was unacceptable to do. So.
Okay. Next question. The feedback from the latest training is much better. Deploying the jacket in the water and use of the spray hood with the EBS being worn is much better. The only thing to resolve is the use of the EBS within the wet drills. They are being seen and used travelling offshore, but what else can we do to check inbound passengers?
So there's probably 2 or 3 things we can do. Firstly, it's the standard stuff. Safety alerts, reminders, buddy checks, all of those things. We're supposed to be doing buddy checks anyway and making sure that we're wearing the equipment properly. and those should continue. But we have a set of aviation guidance in industry supplied by Oil and Gas UK, and making sure that the heli admin, heli deck attendants and HLO are properly performing that, so that they're giving the pilots the best chance of complying with regulations when somebody walks up the stairs is essential. We must avoid that kind of, when somebody's turning and burning on the heli deck, that the pilots is having to manage and check that somebody's wearing their armbands and everything else properly. So it is about us being responsible and taking some personal responsibility for this. If you're an XBR, wear your armband. Goodness me, it's not that big an ask. And if you're not an XBR, then you can sit in any seat if it's available, subject to the centre of gravity and loading on the aircraft. So it's standard stuff. Play your part, personal responsibility, follow the rules, and look after your buddies.
Yeah. So a similar question. There have been a number of occasions where the MK-50s have arrived offshore with damage which has presumably been deemed acceptable to the operator, jacket maintenance personnel, but which the folks offshore have not been happy enough to wear. Is there currently a system by which there is some sort of harmonisation of understanding of what constitutes damaged equipment?
Yeah, I've got to say I'm unaware of any instances whereby we've had damaged jackets. The system we use on shore to record that information, I know across all three operators, is pretty detailed and exhaustive. So I would highly recommend that if you are finding instances where damage to jackets is occurring, then please either advise the crew or tell the operators when you get back on shore that you've had an issue. And if it's an offshore flight, so you're actually heading offshore, then please on the heli operations on the deck report the incidents. But I can't speak for the other two operators, but certainly from CHC, clearly we take the maintenance and the safety of the jacket very seriously. And I can personally say, having sat through all my occurrence review boards in the last 6 months, I've never come across an instance where I've had a jacket reported. So I'd encourage you to feed back any instances of damage to the jacket or anything in particular that you feel is wrong with the jacket. So that would be my response to it. Can I just highlight as well, though, one of the things that we did pick up, and it's something that we are going to follow up through step change. I'll contradict myself a little. We have not found physical damage to the jacket itself, but we do find is chewing gum. I know it sounds quite a little thing, but the jacket itself, just by the fact that you put the rebreather in your mouth, if there's either gum in your mouth or gum in the rebreather, that could cause a problem. And it is something we're going to follow up on. We have had one report of gum being on the jacket. So again, it's in our own gift to make sure that we keep each other safe. So I wouldn't suggest that chewing gum and a rebreather jacket go together and give a safe outcome. So I'll reinstate what I just said. From damage, I've not seen anything, but certainly from a report standpoint, that's the only thing I have seen is a chewing gum.
Yeah, I mean, one of the sort of the let's say features of the Mark 50 jacket and CA ABS is you've got this lovely little receptacle up here for the mouthpiece. It appears to be a lovely little receptacle for disposing of chewing gum as well, and that's kind of neither hygienic nor safe for the person that might have to use this on the inbound flight. So I think it's one of those things. Again, it's not commonplace, but it's sufficient to give us cause for concern and need to do something. But why would we get to the point where you're interfering with a piece of safety equipment, that somebody else is going to have to use? That just is absolutely and utterly, unacceptable for everybody. But we need to manage that. What I can say is that we sit down in step change, and we have on 2 occasions reviewed the performance of the CA ABS with SurviveTech, and that's given us, again, in terms of where they're finding issues, and the performance of the CA ABS, the new jacket, is exactly the same in terms of operational deployment as LAP. So we're not seeing a poorer level of performance. Uptime is in the 99%, but we continue to look at simple improvements that actually make it more robust, bearing in mind we deploy this incredibly quickly.
Okay, just 2 more questions. Can the shoulder measurement not be incorporated into the Bezier FOAT for the offshore population?
The answer is yes. Everything can be included in everything, bearing in mind that that would have to go through a full APITO standard review and approval by APITO standards committee. What we decided was that means you're measuring everybody, which again doesn't make much sense. You know, if you're 45 centimeters, you will never put on 10 centimeters across your shoulders. So by doing this one size fits all doesn't necessarily drive the right answer. By putting in the Bezier, and in everything in life, the more we do, the greater the cost. And if you have a trained medic at site who can do this in your daily routine for no cost, actually just actually manages it manages the right outcome in the right way at the right cost. And that was why we made the decision. You know, this is about having the right cost efficient, safe solution. And there was a risk that we saw costs escalate by putting in Bezier unnecessarily. So that was why we took the decision on that.
And last question about the shoulder measurement. It's impractical that the offshore medics will need to measure as many personnel as is required to keep valid. Everybody will be required to get measured again. Will this be at the same time? And is Calabro set up to raise a flag to be measured?
So not everybody needs measured. So it's only that it's only that population plus or minus 10% of the 55.9, and it's only once every 4 years. So it's effectively a management change process. Is Calabro set up? Or Calabro are, for those that are on the call that don't know who Calabro are, they are effectively the organisation that manages Vantage on behalf of industry. So in short, currently, the answer is Vantage cannot do this, but that doesn't mean to say that it can't be changed to do that. And obviously there's costs incurred, so we have to look at that. But this is, again, it's partly personal responsibility, but it's partly organisational capability. One of the decisions we made around the XBR measurement was not to flag this as an XBR status, and it was actually to enter this physical dimension into Vantage, which then cascades over into XBR or not. So should the measurement change, should we introduce new suits or anything else, we can then begin to manage this in a different way. Now, all of those things require system programming, which results in cost. But this is about managing it in a consistent, ongoing and simple way. And fundamentally, the risk is that if we don't do this, we just don't understand. We get back to exactly where we were a year ago, and we begin to put people in the wrong seats and don't have any assurance that they're compatible with the window they're sitting next to or near to. And that has to be the wrong outcome. So yes, it's a change process, and yes, it will require management as we go forward, but it's dead simple. The vast majority of those 75,000 people were measured by medics at site. So we can do this. Doing that 75,000 over a 4-year period is extraordinary. Our fraction of that 75,000 over a 4-year period is, by a magnitude simpler of doing 75,000 in 3 months.
Okay, this is the last question because I think it's valuable to have this answered. Would it not be easier to capture the shoulder measurements within the offshore medical and recapture on review?
So I don't know who said that, but the answer is yes. Of course it would be. But again, this is about what's the offshore medical for and the purpose of it. And it's about medical fitness. And shoulder measurement is about compliance with regulation, and it's not a health issue. And despite lots of discussions to this effect, doctors do not want to be embroiled in safety compliance issues. They want to give their best medical opinion of whether somebody's fit to do their job. And you can be fit regardless of your shoulder measurement size. And that was where it ended up. So yes, there's always different ways. Would it work? Absolutely. But that's a 2-year periodicity for everybody, which again drives costs up. And it comes back to manage the small population that's going to be in that 10% window, do it at site, low cost, simple, and a lot less disruption to everybody involved.
Okay, thank you very much, Les and Mark. I'd then like to invite Andrew Detto to come and present.
Well, hi everyone, I'm Andrew from Airbus Helicopters. Firstly, welcome to our fleet centre here in Aberdeen. For those of you who are not familiar with what we do here, we've got about 17 staff in the fleet centre. The fleet centre consists of us providing both pilot training, logistics support and technical support to the 4 helicopter operators here in Aberdeen. So we've got a H225 full flight simulator. We've got some millions worth of stock, mainly managed under parts by the hour contracts, and we've got a bunch of tech reps who help the operators on a day-to-day basis to keep the aircraft serviceable. Maybe just for a further little bit of context, there's probably 32, I think today, Airbus Helicopters products operating or managed out of Aberdeen. We've got 2 175s. In the crew change role, we have 4 332 L2s, and then there's 25 or 26 225s amongst the operators. So I'm not too sure what's happening at the slides. That come up, please. Right. So what I plan to talk about today is a little bit of context about what is the fleet status for Airbus helicopters worldwide. Talk about what are the causes of the accidents, which then really gives us a focus on where are the areas where we need to make improvements. And then step through some of those areas where we are focusing on improvements. Firstly, in the operational regime, then the technical event area, and then I'll touch on some of the things that we're doing survivability-wise. But as Les mentioned earlier, our main focus is on keeping the aircraft airworthy and airborne, rather than looking at methods of egress and survivability. Just wait for the slide. Okay. So we've currently got about 12,000 aircraft in service. That's Airbus Helicopters aircraft operating in over 150 countries and with over 3,000 operators. Most of the operators only have 1 or 2 aircraft. Fleet-wide, Airbus Helicopters products and the previous products through Eurocopter, Aerospatiale and the like have accrued over 90 million flight hours, and last year we flew just over 3 million flight hours. So it's an enormous amount of flight hours and an enormous amount of experience that we gain on the performance of our products in service. When we look at the oil and gas market, we've got just under 800 Super Pumas flying today. In the oil and gas market again, last year we accumulated a total of 10 million flight hours on oil and gas missions, and the Super Puma fleet have flown just over 5 million flight hours. Importantly, last year, just on the 225, we flew over 250,000 flight hours. So that's just to give you a little bit of the context of the experience and the feedback that we get on our products so that we can always improve our products. Now, we've had a rough trot over the last few years, especially here in the North Sea, with a number of accidents with our products. And so that has really, prompted us or focused us on really identifying those initiatives that we need to take to make sure that we keep the product safe. So, but before, well, keep the product, and of course, and the passengers and the aircrew safe. But before we can identify where we can make the improvements, we need to have a look at and have an understanding of, well, where do the problems lie? And very importantly, about 2/3 of the offshore accidents on Airbus Helicopters products have an operational cause. And so for us in Airbus Helicopters, this is the #1 topic that we need to address, and I'll spend a little bit of time today explaining to you what we're doing about that. Then there's less than 20% typically have a maintenance cause, and then quite a small percentage have a technical cause. And so I'll talk a little bit today about why that is as well, even though we've got very complicated technical machines, why the technical cause is so low. Traditionally, the way we've managed the airworthiness of our products is through the regulatory and mandatory continuing airworthiness process. And what we need to do there is whenever we have a defect or an issue with our aircraft, we need to investigate it. and then we need to work with the appropriate authorities, typically EASA, who is responsible for the certification of our products, to make improvements either to the design itself or to make improvements to the procedures, be that either an operational procedure or a maintenance procedure. And through that process, which all the manufacturers do, we really control the technical airworthiness of the product, and as a consequence of that, we limit the opportunity for technical accidents or for having an accident for a technical cause. When the 225 started to return to service in late 2013, mid to late 2013, we really had a focus in the company on now going a little bit further, rather than just looking at the technical airworthiness, but looking at the operational suitability and the operational availability of the aircraft. So we work closely with the helicopter operators, particularly here in Aberdeen, to make sure we really understood what were those things that were preventing the aircraft from flying or that were causing events which could be perceived as having a safety impact. And we had this operational availability program, which now had us stepping over the boundaries a little bit from what traditionally we were doing as the managers of the technical airworthiness into the area of maintenance and working more closely with the operators on the maintenance side. An evolution of that is what we've been doing more recently, particularly in the last 2 years, working a lot more closely with the helicopter operators and through the organisation of Heli Offshore, and what we've termed the safety partnership, because as I said in the past, traditionally we'd looked at the technical airworthiness of the aircraft, and it was largely an operator responsibility to manage their operations, operational procedures and their maintenance procedures. Because of the potential, say, for incidents or accidents coming from that maintenance or the operational area, we've worked a lot more closely with the operators in the recent time to make sure that we can together improve in those areas, and that's why it's a partnership, because no party can do it by themselves. Just wait for the next slide to come up. So the first thing really that we looked at doing was making sure that all of the helicopter operators had a consistent understanding of the features within our aircraft. So the 225, as many of you may know, has the best-in-class autopilot. We have a lot of very advanced features on the aircraft that are not available on most, and certainly in the heavy helicopter, it's the only aircraft that has some of these features. Things like altitude and airspeed protections, which are hidden protections within the autopilot. Features like the ground speed mode and the go-around, which can be very useful when employed in the offshore environment. Now, in the past, we had not fully documented, explained or trained how these features work, and therefore the helicopter operators didn't have a complete understanding of how they worked or how they should be employed in the offshore environment. So we spent a lot of time working together for us Airbus helicopters to have a much better understanding of the offshore mission, and for the helicopter operators themselves to have a better understanding of what are the features that are available in the aircraft, and therefore what features can be used during different phases of the mission. And what that led us towards, on the next slide here, is the Flight Crew Operations Manual. So in the past, the OEM, such as Airbus, or Sikorsky or Augusta, had a regulatory responsibility to develop what's termed the Rotorcraft Flight Manual, or the Flight Manual. In the Flight Manual, we have the general description of the aircraft, we have the performance charts and all the performance data, and we have the normal and the emergency procedures. The helicopter operators then take the information in the flight manual and what they've learned from their operations and their experience, and write their own operations manual, which is really their SOPs, which describes what features of the aircraft you will employ during what phase of the mission. And so what we've done with the FCOM is work very closely with the helicopter operators, such that we understand the mission, such that they understand the aircraft, and then in a much more descriptive or prescriptive way than we've ever done in the past, we've written the flight crew operations manual, which says for each of the different phases of the mission, exactly what the pilot flying is going to be doing, exactly what the pilot monitoring is going to be doing. And in that way, we standardise, better control, and put a more robust framework around the operational piece with the intent, once again, to reduce the potential for those operational accidents. And for us in Airbus helicopters, this is the #1 focus or the biggest area where we have the potential to improve safety. Now, that said, of course, we always continue work in the area of continuing airworthiness, and managing technical events is one of the key activities that we do for that. And because we do that, all the manufacturers do that, and we've been doing that for many, many years, the reliability or the technical integrity of our products continually improves. So what I've just done here is I've got a couple of slides on some recent topical events, just to explain to you how we're managing those. So the first one here is the MGB casing cracks on the 225. Over the last 2 years, we've identified 6 cracks in the casing. You can see where the cracks occur near the input module, on the main module where it interfaces with the epicyclic. These cracks have varied in length, but they've all been quite short. They've all but one have been identified in service during the normal maintenance checks, which typically happens every day or every second day, depending on the utilisation of the aircraft, because the check is done every 15 flight hours. And as a result of that, we've implemented improvements. So when the gearbox is now in for repair, we actually polish that web so that we remove the stress concentration or sites where we could initiate the crack through stress concentrations in the web. What we're doing on the new gearboxes that we're manufacturing is looking at how we can incorporate that improvement now. And we're also looking at how we can do that improvement in service, so we don't have to wait till the gearbox goes back in for an overhaul or in for a repair before we implement the improvement and therefore avoid the crack. But the important thing here is that we did a full finite element analysis. We did a stress analysis on the gearbox casing. We understood during what phases of flight or what missions we have sufficient stress. If we do have a small defect or a stress concentrator in that web, how we could initiate and then grow a crack. We know something about how the crack grows and the growth rate, and therefore we can manage these things in service. And I was speaking to some personnel from Shell through a similar thing to what we're doing today, maybe a month ago when we were first discussing this issue. And I had to remind myself that it was in 1989 when I first came into the area of managing aircraft and being involved in aircraft. And I was about to go on a flight on a Pilatus Porter at the time, and one of the technicians was going through the aircraft log with me and explaining to me a check that he needed to perform when we concluded the flight. And one of those checks was to measure the crack length of a crack in the main wing spar on this Pilatus Porter. And at that point in time, I wasn't involved in aircraft, and I was absolutely horrified that we would have a crack in a main spar on an aircraft, and we were about to go flying in that aircraft. But over the years, I've learned and I've become familiar with that. We manage defects on aircraft similar to the way defects are managed in the offshore installations. We have very robust processes around that on how we do the risk analysis, how we put preventative and protective measures in place. And so it's something that we normally do. And while it may sound quite unusual, maybe even scary to have a defect on an aircraft that's in service, it is a normal part of the business. And because we've flown so many flight hours on our aircraft and we get the feedback on all of these defects, we do have the experience then to manage the defects and to keep the aircraft in service and keep them safely operating. Next slide. It's coming. Okay. Some of you may have seen that yesterday evening we issued an alert service bulletin for the cabin window jettison. So here's another example of a continuous improvement or how we're managing a technical event. We had a VIP operator who reported to us that during his 2-yearly maintenance of the aircraft where you need to jettison the windows, that he had difficulty getting one window out. This was a VIP aircraft. In the VIP aircraft we have thicker transparencies than we do have in the normal offshore configuration. And this was the first time that we ever had an operator report to us in over 10 years that they had difficulty in jettisoning a window. So we performed an investigation. We jettisoned over 150 different windows on a bunch of different aircraft to try and understand whether there really was a problem. And what we found through that process was that there is some degree of variation in the amount of effort required to jettison the windows. So what we've decided to do is to place a piece of Teflon tape around the frame upon which the rubber seal mounts, so that the rubber seal then can more easily slide off the frame when you need to jettison the window. Of course, we've discussed this with the authorities. We expect the EASA to issue an airworthiness directive today or in the coming days. And we've got a compliance period of 110 flight hours for those aircraft that are operating offshore. We've had the material here in Aberdeen to do the change. We've liaised with all of the helicopter operators, of course, and we have some technicians coming on site tomorrow to help with the changes. So once again, it's just another example of a technical event or a continuous improvement and the way we're managing that through. My final slide, I think, is just recapping on where we're at for the shaft retrofit. You may recall that back in 2012 we had 2 power-on controlled ditchings on 2D5s here in the North Sea. That resulted in a suspension of flying operations, and it wasn't until June of 2013 that we properly understood the root cause. We had the safety measures certified, and therefore we were able to manage the return to service of the aircraft under those safety measures. It was almost 12 months after that when we had the certification for the new redesigned shaft, which takes out the areas for potential failure. That was then independently verified by Professor Burdekin from Manchester University, organised through Step Change. And then in the middle of that year, in 2014, we started delivering the first aircraft off the production line with the new shaft. And then when the gearboxes started coming out of overhaul, we started delivering those with the new shaft. And then in September 2014, we started the proactive retrofit. We started here in Aberdeen, working very closely with the operators again to bring aircraft offline. And even when the gearbox wasn't ready for an overhaul, we would do the shaft replacement. We did almost all of the aircraft in Aberdeen here that year in 2014. And I think we had 2 aircraft that were waiting for overhauls of gearboxes, which were done by February in 2015. Our target was to do all of the offshore fleet within 12 months. That was 117 aircraft, and we did that. By September of last year, we had all of the offshore aircraft done. We had planned by about this stage to have finished all of the non-oil and gas aircraft. They're mainly military aircraft. We've done 73% of those. Also in January, we had 73% done, which is 113 aircraft. We have had some difficulty gaining access to some of the military aircraft that are more of the low-flying aircraft, and the operators are not so impacted by the safety measures, and so therefore they're not so motivated to have the change take place. So that's why we haven't completed all of the non-oil and gas aircraft to date. Importantly though, is we've flown over 100,000 flight hours on the new shaft now, and previous to that we flew over 150 flight hours under the safety measures, and of course we haven't identified any cracks. Oh, sorry, I haven't got a final slide, but it'll be a quick one. So I spoke a little bit about what we're doing to avoid the operational accidents. Spoke a little bit about how we're managing technical issues so that we avoid technical accidents. And my last slide here is on what we're doing in case we do have an accident, then how we can improve the survivability on the aircraft. So for the last 2 years, we've been working on a number of improvements, and we recently hired Felt Train Services and their Hewitt Underwater Escape Trainer to trial some of the improvements that we plan to put into our aircraft. And Alan from TACO will talk a little bit more about some of those trials because he was involved in them. We had some of our workforce members involved as well. What we're also doing now is we've got some jettison handles that we're putting in the aircraft. So the first ones are on the jettisonable windows. We've got a new handle. You can see that in the top right picture there. That has been certified now and has been ordered by a bunch of the operators and will be fitted to aircraft soon. The next one is the life raft jettison handle. So this is, currently you can jettison the life raft from the cabin, so the air crew, from the cockpit, sorry, so the air crew can jettison it. From the cabin near the door, we've got a handle, and also you can physically pull the life raft out of the sponson. But if the aircraft, in the event that we have a water impact and the floats get ripped off and the aircraft rolls over, it's difficult to jettison the life raft. So what we've done there is we've designed a handle to be placed on the bottom of the aircraft just forward of the cabin door. That's been validated with the operators and that should be certified later this year. And finally, we've redesigned the cabin door jettison handle. Once again, it's been validated and the design should be certified later this year. I think that's it for me. Do it again. Done it again. Oh, there you go.
Yeah.
Any questions, were there? No? Okay, that's good. Righto, Alan, well done.
Good afternoon. My name is Alan Smiley. I'm a TACA Britannia Telecoms Technical Authority. I also work with the Joined Up Thinking team within Step Change and also in the Workforce Engagement Support team. There we go. It catches up. So today I'm going to go through a couple of discussion points from the testing that Andrew just mentioned there. And what I'm going through is why do we have workforce engagement as part of this? What was the experience like and what feedback were we able to pass back and to have discussed on the day? Just wait till we catch up here. So as part of workforce engagement, so in the UK and the UK continental shelf, there's legislation that provides for workforce safety reps to be involved in different activities on a platform, and that's under SI 971. It tends to sit within each company, and through Step Change, we have access to work with these teams, especially with a group called G18, and the G18 is a group of volunteers that have come to Step Change from these companies to help work and to provide assistance on activities like this. Benefits to this approach for us is it's easy to communicate information that we receive from things like this back through the network. We have actual offshore experienced people involved in a number of these activities. Safety reps get to be part of something a bit bigger, and also we're able to bring up kind of broadside issues, so things that people would not normally think about, things that we're able to bring up and see where our heads are, what we're actually thinking as a workforce rather than what people are thinking that we're doing. So on the day when we were doing this testing we were invited in here, there's a couple of us invited in. It was myself, with Bob Egan from HSSG, with Euron Events from the G18. And so we all came down along with Emily to take part in the testing. So before it started, we went through a briefing of the objectives. We had no surprises there, it was good. We were told exactly what we were supposed to do. We were able to do a dry run through all of us had different seating arrangements, what we were supposed to do, how we were going to get out of the aircraft. We had divers there as well that were acting as our help with this, so they were also getting a briefing so everyone knew what to do. When we actually got to the water portion of it as well, we all were using lap jackets. The divers were using EBS just more for ease of testing and to comply with the regulations. It was interesting watching the trained divers using the EBS, and that was quite a positive experience for us there as well. We went through the holding breath exercises. We went through extended use of the lap jackets. The testing that we were doing involved staying underwater for longer than the normal 30 seconds. So we were doing our testing up to a minute and making sure that everybody was comfortable with the exercises and what we were doing. At the end of the day, for us, there was nothing new. It was basically along with what we'd previously done in several years before, up to this point with Bosnia and with Hewitt and doing the testing there. Part of the time was being aware that there was GoPro cameras positioned around about the rig, so everything that we were doing was being watched and monitored, and to be comfortable with that. And at the end of that preparation, we basically had a bunch of volunteers ready who knew exactly what was going on and were quite keen to get on with the testing. Oh, there we go. So just wait for another one to come up here. So in a second here, there'll be a couple of pictures come up of what the actual testing looked like. It was a standard test rig for us. You'll see by the pictures that the seats were adjustable within the cabin, and they're positioned to do different scenarios here. These pictures are actually just taken after the testing, so there's a little bit of change of where the seats were actually on there. On the left there, again, other pictures about to come up. So two pictures that are coming up here. The one on the left indicates the actual rig that we sat in. You can see that the windows there on the outside and the ability of the rig to capsize. On the right is the one with the pool that we were testing. So we were asked to volunteer to come down and test different scenarios based on positions of a handle that was being put next to the window to allow us to escape. So we didn't have much knowledge of what was going on beforehand. From our point of view, we saw the handle on the left of the windows. The positioning of the seats were offset from the normal Bosnia, so when you do the normal escape training, you're right next to a window. The window itself is always very easy to knock out. It's an easy activity. This one was a little bit more realistic. We had the rip cords around about the windows every time that we did the test, and the positions of the escape meant that sometimes we weren't as close to a window as we would like to have been. Part of the deployment, we had several times that we were coming in and out of the aircraft, different times we were capsizing. We were giving timings and when to escape out the aircraft, so we would sit and maybe let somebody else go out ahead of us to test the handles. On some occasions we weren't to use the handle and to see how difficult that was as a comparison. And then finally we were doing capsize exercises along with the normal orientation of the aircraft. This next slide that is going to come up here. Here we go. So this basically sets the set of the arrangement within the aircraft of how we were doing it. I personally was in position 1, Bob Egan was in 2, with Joran in 3, and another volunteer that was sitting in the 4th position. And these scenarios were basically done like this throughout the day. We had to get out, and as you can see, different times, different orders, we had to escape. Especially that position 2, going to his right to go round about the seat was quite challenging, but it allowed for a bit more of a realistic setup. We were quite congested in there, we were quite close to each other, and gave an added dimension to how we were able to actually escape out the aircraft. These are a couple of pictures of what it was like when we were in there doing the testing. And oh, it's just taking a second to come up. There we go. So here's a couple of pictures of what it was actually like inside, and on the bottom left you can see how we were using the GoPro. You can see from these pictures with the EBS being used that these were the divers who were also doing testing as well. So they would go in and do their bit, see the effects of them coming out, and then the next time it was myself and the other volunteers using the lap jackets to do a similar type of exercise. We'll just wait for this next slide to come up. Okay, so as you can see within this one here, we would the focus from from them was on the position of this handle, where it would be and what would be the most used to escape out the aircraft. And the testing was based on that. There was some times within there where you got used to using the handle, and then and even in a capsize situation, this was something that was a very positive thing, but when you didn't use the handle, which is about halfway through our exercises, you really noticed the difference, and your time to escape did differ significantly. At the end of the day, when we were doing the testing, we were given sheets to fill in to give us some feedback on what we thought of the experience. And through that feedback, we were able to initiate quite a bit of discussion. The discussion of the handle position, the size, for example. The discussion of the testing team was of the position of the handle, and for us there was it's a better idea maybe to extend the size of the handle and where it was, and to maybe look at that. We had discussion about whether the handle really helped us at all, and it was quite a positive experience for us. All of us agreed that this was a definite positive for us. Not so much in just being able to pull yourself out, but it helped you locate the window, it helped you provide some leverage when you were knocking out the window and pulling the ripcords off. And then finally there was some discussion over the handle colour. Would put reflective strips being on, would maybe change the shape. These things would help you in the escape. And these things that we were discussing was quite positive for us, because while we were doing that, we felt that we were being listened to. Some extra parts of the feedback, I don't know how intentional it was for us, but as part of the process, for the guys who were doing the test, we've all done this several times over our careers offshore, but getting that time to sit and work within the cabin and do these testing was actually quite a big booster for our confidence. Certainly made us rethink what we would do in the event of any times we'd have to use this training, especially having the windows being offset and not being where we are. We thought this was a great plus, and also having the congestion in the cabin, having people in there not in this nice easy environment to get out. Certainly these things were a positive to have, but for us being a little bit more experienced, it was a nice thing to be able to see and get to spend the time doing. And also the sitting around, there was a lot of time we were sitting waiting for the scenarios to be set up. There was times where there was adjusting the cameras around a little bit. It gave us time to sit and work and talk to the industry representatives. It gives us some thoughts about where their heads were and what the thoughts were, why they were doing a lot of these different activities. We were certainly the reasons that we thought some of the things were in place were not quite what had happened there. And it was really good to get that feedback. And just again to reiterate that at the end of the day we were being listened to, and that was a positive thing for us. We were, as typical safety reps, being quite vocal and not pulling any punches about what we thought was going on. It was just good to be able to get that. And just moving on here just to my final slide. Certainly coming out of that, there's a few expectations that we would like from that, and certainly if it's progressing the way that we were going. There's a lot of collaboration that we felt was going on. We felt again that we were listened to, and that there was some positive things that were going on, especially in the day one exercises. The hope is that proper managed change will occur. We've got some great processes here within the industry, and the hope is that we'll not bypass these, but we'll look at all these things properly so that these changes that are being made can be put in, we can be used, and we can be trained on. And then finally, that safety is progressed by this kind of innovation and not by bitter experience. It's good to be able to test these things out and not have that done being in anger. But I'd like to thank you for listening to my portion.
I'd like to invite Andrew back, and we have some questions. So our question relates to, Alan, your presentation. What we're gathering from this is how unrealistic the usual training scenarios are compared to a real situation. Are we still confident that the training is sufficiently representative to be of value?
Absolutely. The training that we were on there and the experience that we've had is based that we've done this for for several years and over several times. To lead in to get this training, it was definitely good. There's no doubt about that the Bosworth and the Hewitt as it stands right now equips you with the tools to be able to escape out of the helicopter. There's no doubt that getting that extra time getting in there is a benefit as well. But over and above the basic experience that you need to get out of a helicopter, no, my belief is that the Bosworth and the Hewitt fulfills that requirement.
Les, do you want to say something?
Yeah, wow. So I think just to add to Alan, is that we have to be incredibly conscious of what the Bosworth and Forward are there to do. They're there to provide that basic training. They're there to provide and build confidence in underwater escape training. We certainly do not want to be in the situation where we're simulating real life events. This is not meant to terrify people or put them in place of harm. This is training to build confidence, build experience that, in the unlikely event of accident, that you have sufficient information and understanding to make good escape. And certainly from the events of the past 3 or 4 years, we know that Bosworth and Forward training has provided people the confidence to take the right actions. So you cannot put 6 people in a helicopter simulator and drop them into a pool uncontrolled and expect things to be okay. This is about simulation and building confidence as opposed to the absolute reality of the unlikely event of being in a helicopter incident.
Thank you. We don't have any more questions at the moment. Is there anything else that either Andrew or Alan you'd like to close up on? No? In that case, I'll put you on this way. Thank you very much for attending our helicopter safety webinar. I have 2 more questions for you. Oh, sorry, I have 1 more question for Andrew. Are they planning and engineering the requirement for the sticky tape?
What, sorry?
Are they planning and engineering in the requirement for the sticky tape?
Yep, so for the tape for the jettison windows, we delivered the tape either on Friday or Monday, that to the operators here in Aberdeen. We've also made tape available around the world. So one of the operators here is starting the change today. I know one of the others is starting on Friday. They're scheduling all the aircraft in. So yes, engineering is planning when the aircraft will come in for the change, and our technicians, as I said, arrive tomorrow to assist in that process.
Great. And another question, how long before we will see the handles in the helicopters?
For the window jettison handles, some of the operators are taking the opportunity while we do this, put the Teflon tape around the frames, but they're also going to install the new jettison handle. We've had, of course, we weren't expecting to do this Teflon tape alert service bulletin. We had a number of handles available. They have now all been ordered. So our stocks are somewhat depleted right now. So unfortunately, we won't be able to get them in all the helicopters while we do this change. But yeah, it's giving us this opportunity. So within the coming weeks, certainly here in Aberdeen, we'll start to see the new window jettison handles in the aircraft. For the grab handles, it's going to take a little bit longer. We need to modify, because they need to be mounted to the structure of the aircraft. We know after the trials where we want to put them now in the aircraft. The exact size and position, the vertical position of them is still subject to some more study. And we need to make some structural changes to the aircraft. So we won't see those this year. We will see them next year. For the life raft jettison and for the, what was the other one, the cabin door jettison, we expect both of those will be certified this year. And then the service bulletin for the modification should be available next year. So we'll see them in the aeroplane next year.
Okay. Thank you very much. Well, on that note, I'd like to now thank all our speakers for presenting today, and thank you all for listening. We have 2 final questions. This is the first time we have run a webinar like this instead of our usual event at the Exhibition Centre. So I'd quite like to answer 2 quick questions for us, if you don't mind. The first session is, did you find this useful? We've got 80% of us who voted. So on the whole, it's either yes or partly. I'm glad to say that nobody has said no. It certainly keeps me in a job, so thank you. And our second question for you is, would you attend a step change webinar again in the future? And that's 80% of you have said yes, which is very good news. Okay, well, thank you very much, and I think I'd like to formally close down this webinar. Thank you very much.